In this video, we'll be looking at the common denominator strategy for comparing fractions. When we think about drawing a visual representation to help us understand this method, we'll always start by having a standardized whole, a same-size whole, and then we'll partition into equal-sized parts, that's the common denominator, and finally we'll compare the numerator, where we're just counting up the parts. Let's start with an easy one, 1/4 and 3/4, and use an area model. So first I'll pick my reference whole, and I'll use the same one for the second fraction. Because we already have the common denominator of 4, we'll partition the whole into 4 equal parts, and then we can shade according to the numerator. So with 1/4, we have 1 part worth 1/4 of a whole, and with 3/4, we have 3 parts, each worth 1/4 of a whole. Same size whole, same partition, so same size parts, and now we're just counting the shaded parts. Clearly 3 is greater than 1. It covers more area. This is our area model, so we'll say 1/4 is less than 3/4. These comparisons work particularly well on number lines as well as area models. So we have our reference whole, our unit, the space between 0 and 1, and we've broken it into 4 equal parts. Those are our 4 spaces. So we have 1/4, 2/4, and 3/4. When we mark 1/4 and 3/4, we can see that 3/4 is to the right, so it's greater. Another way to write this would be 3/4 is greater than 1/4. With equal size parts or equal size spaces here, all we do is compare the number that we have, the number of parts or the number of spaces. Let's do an example where we do not have a common denominator. Let's keep 3/4 and compare it this time to 2/3. Now when I go to draw my whole, I have to be careful because I want to have the same whole and I want to have it easy to partition. So as I do this, I'm going to draw a rectangle. Rectangles are easier to work with than circles, and I'm going to have one side be 4 units long. That's because my denominator is 4, so I'll be breaking into 4 parts, and I'll have the other side be 3 units long. That's because in my second fraction, the denominator is 3, so I'll be breaking into 3 equal parts. Once I've established my whole, I need to keep it the same throughout the problem. To show 3/4, I'll partition the whole into 4 equal parts and shade 3 of them. 3 parts, each worth 1/4 of a whole. On the right here, since I have thirds, I'll partition it into 3 equal parts. I'll shade 2 of them, and now I have 2 parts, each worth 1/3 of the whole. So I have the same size whole, but I don't yet have equal size parts. So I can think about what a common partition would be. I'll take my denominator, 4, and I'll list multiples of 4. 4, 8, 12, 16. I'll take my denominator, 3, and I'll list multiples of 3. 3, 6, 9, 12. I can see a common multiple is 12, so I want 12 in the denominator. For this first fraction, I'll have to multiply the numerator and the denominator by 3. And for the second fraction, I'll have to multiply the numerator and the denominator by 4. So I want to compare 9/12 and 8/12. When I adjust my drawing, because I set it up with 4 units on one side and 3 on the other, I can just transfer my 3 sections on the right here. So these vertical lines, I can transfer my vertical lines over to my drawing here of 3/4. As soon as I transfer my vertical lines, you can see that I have 12ths, and I have 9 parts, each worth 1/12 of a whole. On the right, I'll take my horizontal lines and trace them in. And now you can see that I have 8 parts, each worth 1/12 of a whole. Well, we can see that if we count up the shaded parts, right, we have the same whole. Now we have the same partition, so the same size parts, the same denominator there. And I can see that 9 parts each worth a 12th is more than 8 parts each worth a 12th because 9 is bigger than 8. So 9/12 is greater than 8/12. All that mattered in the end, once we got the common size part, was the number of parts that we had. We could have also done this with a linear model. In this case, it's important that we have the same distance between 0 and 1, regardless of what fraction we're talking about, so the same whole. And then I can mark my fourths. I can see that 3/4 is going to be further to the right than my 2/3. Since 9/12 is to the right of 8/12, it's greater than 8/12. The distance between 0 and 9/12 is greater than the distance between 0 and 8/12. With number lines and common denominators, it's really easiest to start with the common denominator and fill that in. So rather than starting with the initial fractions, it might be easier to figure out the common denominator first and draw that in.